Hey, how's it going? Today we're going to be talking about antibiotic use and why it is bad. First, we're going to touch on the history. Paul Ehrlich was a German physician who discovered arsphenamine, but they didn't really use it until Alexander Fleming discovered penicillin in 1928. He will go on to win the Nobel Peace Prize with Howard Florey Ernst, who assisted him in the discovery and the usage in antibiotics with it. Small doses of antibiotics actually was proven to stimulate growth in animals. It was discovered by chance by researchers in the 1940s. It only started really being used by D-Day in 1944, which saved literally millions of lives that day.
For ethical aspects, it has to do with animal health and antibiotic resistance within animals. This could be a negative effect on health when diseases cannot be treated. Many animals can end up dying from diseases if they develop resistance to the antibiotics they are receiving, and the overuse of antibiotics on the animals can harm them. Another reason is for public health. So I put two quotes here. A systematic review published in the Lancet Planetary Health found that interventions that restrict antibiotic use in food-producing animals reduced antibiotic-resistant bacteria in these animals by up to 39%. When meat producers misuse antibiotics important to human medicine, especially those that are considered critically important, resistant bacteria can rapidly multiply, spread off the farm, and potentially infect people with dangerous illness, said Matt Wellington, antibiotics campaign director of the Public Interest Research Group. If we lose these life-saving antibiotics, we lose the foundations of our modern medical system. And right here, I inserted a video on antibiotic resistance and food.
Antibiotics are supposed to kill the bacteria that can make us sick. But when bacteria are resistant, they're not killed. Then they can continue to multiply, even in the presence of antibiotics. This limits how we can treat those infections. It's important to note, it's not the person or the animal that becomes resistant to specific antibiotics. I don't get antibiotic resistance, but it's the bacteria in the person or animal that become resistant to antibiotics. Resistant bacteria can spread around among people, among animals, and the environment. Antibiotic resistance is one of the world's most pressing public health problems. Illnesses that were once easily treated with antibiotics are becoming more difficult to cure and more expensive to treat. Infections from common antibiotic-resistant foodborne bacteria, such as Salmonella, can cause more severe health outcomes than infections with bacteria that aren't resistant to antibiotics. And in some cases, antibiotic-resistant infections can lead to serious disability or even death. Antibiotic-resistant bacteria can spread from a sick person to family members, schoolmates, and coworkers, and affect entire communities. Bacteria develop resistance through the instructions that are provided by their DNA, the genetic material, the genes in the DNA. Sometimes the genes that cause bacteria to become resistant to antibiotics can move from one bacteria to another. They can move from harmless bacteria living in our bodies to disease-causing bacteria, making the disease harder to treat.
The use of antibiotics is the single most important factor leading to antibiotic resistance around the world. And repeated use of these antibiotics can increase the number of resistant bacteria in humans and animals. Antibiotics kill bacteria that cause illness, but they also kill good bacteria that protect our bodies from infection. Drug-resistant bacteria then grow and are able to take over. Some bacteria give their drug resistance to other bacteria, making diseases harder to treat. So the responsible use of antibiotics in the community, in healthcare settings, and in food animal production is key to controlling the spread of resistance. CDC estimates that more than 400,000 U.S. residents become ill with infections caused by resistant foodborne bacteria every year. People can get infected with harmful bacteria, including the resistant ones, by eating undercooked or raw meat or by contact with raw meat during food preparation. When antibiotics are given to food animals, some of the bacteria those animals carry may be resistant to antibiotics and can survive and multiply. If those resistant bacteria contaminate the meat or other animal products, then people may get sick with the resistant bacteria.
It's important to consider both human and animal health because bacteria, including antibiotic-resistant bacteria, can move from animals to people and from people to animals. Scientists around the world have found that antibiotic use in food animals can lead to antibiotic-resistant infections in humans. However, we can't stop all antibiotic use in food animals. Antibiotics are valuable tools for reducing disease and suffering in people and animals. Antibiotics must be used responsibly in both human and veterinary medicine.
A good way to start is avoiding infections in the first place. This reduces the amount of antibiotics used, and it also helps reduce the likelihood that antibiotic resistance will develop. Ways to avoid those infections and help prevent antibiotic resistance include hand washing, preparing food safely, vaccinating people and animals, and infection control in healthcare settings and on farms. We also need better tests to diagnose what the illness is caused by and which antibiotics would help, and use antibiotics then only when needed and as prescribed.
For this slide, I chose to make a flowchart that shows the transmission of antibiotic-resistant bacteria among food-producing animals and how it gets to community members. This right here is Amy's slide. She did cultural and sociological importance, and she wrote, researchers who have documented the results of Europe banning the use of antibiotic in livestock, resistance to antibiotics have dropped in humans and in the animals. According to the article, Farm Antibiotics Use Getting Worse Before It Maybe Gets Better, in National Geographic, the reason change is being demanded is because the drugs used on animals are functionally identical to many drugs used in humans, which means when resistance develops as a result of farm use, the drugs won't work to combat infections in humans. You can see that overlap in the report too. Over 4 years, the use of tetracycline in agriculture rose by 13%. Cephalosporins, a class that includes the popular drug Keflex, by 37%, and penicillins by 40%. And here is a current event. The most current event that Amy found was an opinion article on antibiotics in meat could be damaging our guts in the New York Times. The misuse of antibiotics have caused the death of 23,000 Americans and also financial losses, $34 billion. We should be concerned about the dangerous factors that the antibiotics are doing to our body and also the animals. Another current event that I found was that antibiotics crucial to human medicine are still being used in unacceptable quantities and on U.S. livestock farms, despite rules brought in last year intended to curb their use and combat the spread of deadly superbugs. So antibiotic resistance equals a public threat. It was estimated to kill 23,000 Americans each year and 700,000 people around the world. The FSIS data show that there had been no reduction in the number of antibiotics turning up during testing. In 2016, the year before the restrictions came into force, the number of residues of the highest priority, critically important antibiotics was 363. The number actually increased in 2017 after the new restrictions to 461. FSIS is the Food Safety and Inspection Service. They are a federal agency. So regulations were brought in on January 2017 that ban the use of antibiotics to make the animals fatter. The question that arises is the use of antibiotics for growth promotion or disease prevention? So to sum it all up, those against antibiotic use argue that it increases antibiotic resistance. When these antibiotics are overused just to produce fatter animals, then it can result in antibiotic resistance. This is a problem because when misused, harmful and resistant bacteria can multiply rapidly. The spread of these bacteria can infect people with dangerous illnesses. Treatments may not work in drug-resistant bacteria. The problem would be infecting several people, then producing a supergerm. The controversy is whether or not these antibiotics are being used correctly and safely. And for the last slide here, we inserted our sources.